Good morning, everyone. My name is Errol Koolmeister, and I'm the chairman of the Nordic Data Science and Machine Learning Summit 2021. And it's my pleasure of welcoming you here. Welcome to my opening keynote. So, we've experienced quite a lot of development in the community the last 5 years. One of the topics I really want to address today is the topic of scaling AI. As many of you know, we've gone past the stage of proof of concepts, industrialization, taking it into production. But how do we, in the companies that now are applying AI, are doing it for real? And what is our target to actually be able to have all of our processes amplified by AI? So, let me take you through the journey of H&M that I'm currently working for and advising. We started in 2016. I'm sure many of you have heard this story before. But what we did was that we focused on the activities and the use cases that had value associated with them. We looked at the value and the feasibility, and we looked across the entire value chain. So we did successfully implement many use cases around personalization, balancing of warehouses, fashion forecasting. For us, it was so successful. So we now just recently decided within H&M that we're going to have all core operational decisions amplified by AI in 2025. I would say that's a relatively huge commitment, and it's going to take a lot of brain power to reach that. And when I say it's going to take a lot of brain power to reach that, what am I getting at? Well, as many of you probably know, as machine learning engineers and data scientists, it's not as easy as just go out there, build a model, and you're done. What we realized when we were trying to scale our first vertical use cases in the organization is that, of course, there was a resource constraint. You, today, are one of the most sought after resources in the market. I can't clone enough of you to scale the capabilities that we need to become successful at implementing AI at scale. In addition to that, when I started looking at the use cases, I realized that many of these use cases are inventing the wheel over and over again. There's a lot of duplication, a lot of waste, a lot of going against the lean principles that they've been teaching for many, many years. We also saw that the development times in starting use cases up were way longer than they used to be. What they used to be in software development, that is. We started seeing that the data science process could go on for several months without generating value. How can we do it faster? We also realized that for every data scientist we were hiring, we needed 3 engineers. So even though we could find brilliant data scientists, we couldn't find enough engineers because there weren't just enough in the market. In addition to that, we realized that the way we identified and the way we picked use cases weren't the optimal solution. Sometimes it was just gut feelings. Sometimes it was really unclear why we prioritized certain things. We needed to be better. In addition to that, we had a slow time to market. So when we were done, why couldn't we get the users to actually use the things? And rolling things out globally takes a lot of time. In addition, we realized there were a lot of best practices, as there are when we are creating a completely new field. We also realized that there were a low data and AI literacy across the organization, not just in organizations I've been working, but in general. Even though we are brilliant in creating new data-driven products, our end users, our stakeholders, they are not good at understanding what it is we're doing and how to utilize this new technology. So, what we did in the beginning, creating these vertical capabilities, and remember the first slide I showed you around our use cases. This here is actually the different architectures that we created. Remember, we almost had similar processes, even though there were different business problems. We had a common data layer, but all of these architectures were created in isolation. Remember the point I made about waste and duplications, and they were set up as autonomous teams. This was very good when we wanted to focus on value fast. This was not so good when we wanted to scale. And what we then realized is that there was value in unifying the architecture on how to go to production. Because what we realized is that our costs were skyrocketing. If we were going to cover all operational processes with AI, can you imagine the cost of maintaining that type of infrastructure? How can we actually work smarter with the technology, not just throwing and burning money at it? There's an efficiency discussion we need to have around these topics. In addition to that, we also realized that the data scientists were the jack of all trades. They were supposed to be software engineers, they were supposed to be machine learning engineers, data analysts, product owners in some cases, and they did everything except the modeling. We wanted it to become more convenient for the data scientists to develop models. We wanted them to be able to focus on these things, not just do everything. It's okay in the beginning, just as in any startup where the CTO had to do everything. When you're starting a new organizational unit, you have to have T-shaped individuals, being good at many things, being a specialist in one. But as we scale, we need more specialists. There is an economy here that makes sure that you can focus on the things you're good at and other people can focus on things they are good at. Comparative advantages. We also wanted it to be easier to run and build individual models with a modern architecture so that we could deploy much faster. In addition to that, we wanted design for developing common assets. As you saw the different architectural patterns, it wasn't enough just having a reference architecture, a guiding star on where we wanted to go. We wanted assets to be reused and shared across everything. And then the question about security. When I joined H&M, I was appealed, I think it might be a strong word, but it describes the feeling that data scientists were sharing notebooks between each other, sharing the password, logging into the same clusters. How could we work smarter, more secure, and make sure that things were privacy guided, privacy secured as well? We want to make sure you should only work on the things you should work on and that you take responsibilities for the commits that you do in the organization. So after doing these things, we started understanding the computational patterns. In the beginning, with the version 0.1 of our reference architecture, we divided this into different process steps for creating our guiding star. And these were basically stumbling steps into picking architectures, into picking patterns based on the architectural patterns in the backend. So we started moving more towards Databricks and data lakes type of integrations. We were better at containerizing, and then we were better on the workflow around how the different patterns were going to go from creating into deploying, how we were tuning these type of things, how we were packaging offline deployment, online deployment, and then also how we were tracking these things. And as I said, this was relatively long time ago for us. Well, for me, it was 2 years ago. Not in a lifetime, it's not long, but it feels like it's been 100 years. So what we then wanted to shift the conversation from, not just going from the technical focus, we wanted to talk about capabilities instead. What is needed to become an efficient data scientist? What is needed to become a good ML engineer? What is needed to become successful as a company in applying AI in your organization? What we started seeing is that these capabilities are the assets that we want to be able to reuse. Some of you know that MLOps is still a big thing on operationalizing these type of things. But what we talk about here is creating the underlying data capability on our tech data platform, because data, of course, is the great enabler for us. And I'll get back to that in a few minutes. But then on top of that, what were the AI, machine learning, data science capability? It was everything from how you develop the models, how you productionalize the models, how you were doing the industrialization, how you were having a control tower, how you were doing AI literacy to upskill your stakeholders, visualizations, documents and cookbooks, because you need good documentation, and also reusable output. So you can easily incubate new use cases. You create the same capability for multiple processes and the same output for multiple analysis. So that your users, because at the end of the day, you're producing something for someone like product teams, like a business unit, like an end user or consumers, so they easily understand and can create values for the rest of the organization. So that's why we shifted the conversation to capabilities. That also took us to the advancement of the architecture, the conceptual vision on how we productionalize things. We started looking at these different capabilities. So how do we do data flow automation? How do we do data labeling? How do we do a query engine, for instance? What type of capability and what tool and technology should we build or buy? I don't believe in that you should do everything yourself. I believe that you should identify what process you want to do something for, you evaluate the options, and you do what makes sense. And you do so without locking yourself in too many things. And when you understand the process, you can then scale the process. It is as simple as that. Understand what you're doing, and then you'll be the best at it. So, what we also started seeing now was the people aspect in all of this. So if our previously successful model with creating product teams that were autonomous and could do pretty much whatever they wanted as long as they gave the effect we wanted, we also did the math. And bear with me here because this is super advanced math. You can have a team of 8 and then you have 8 people. If you have a team, 10 different teams and you have 18 different teams, you have 80. If you have 100 teams, you have 800. Did you follow the reasoning here? Okay, the reasoning is basically we can't hire 800 people to run these teams. So how do we work smarter, not just harder? Because there is a scarcity in the resources we have. So how can we make sure that the business actually are able to scale without us? And I know that's super scary because I can promise you won't be out of a job. But how do we make sure that it's easier for them, that we lower the barriers of entry, that we focus on what we're good at and they focus on what they are good at? So what we did was that we started creating these central AI capabilities. Remember the pyramid I showed you a short while ago? These are the capabilities that we talk about. So in the current organization that I'm working in, we're now going from the product teams doing everything themselves, being fully autonomous, into our domains out in the organization, like assortment, tech enablement, customer fulfillment, etc., that they can utilize these type of resources. So when they do model development, they can utilize the infrastructure we've set up. They use infrastructure as a code and they are up and running. Imagine that. It takes them a day to set it up rather than 3 weeks. That is minimizing waste, and that's what we want to get to. When they're productionalizing, their clear code and template on how you productionalize in H&M. Imagining being able to go to production in a few days rather than a few months. That is reducing waste and duplication. So when we are scaling, we talk about capability, we talk about reusable assets, and we design for everyone the general process and we adapt to the specific one in the product teams that we are now also enabling. So work smarter on the problem, not just harder. And I also think we need to touch upon this, but I'm briefly because I'm not a data expert, even though I work with data on a daily basis. We also have to see that the evolution of the technology, especially us coming from traditional company with the on-prem legacy. That when we started and when I've been going through this journey, it was on-prem. It was building up these clusters. We saw the evolution of the cloud coming, and hopefully many of you out there understand that there is legacy behind this. But if you were born digital, you can totally disregard this comment. But we are still in the world where we have working with on-prem, working with cloud, it's still relatively simple. Still many of you just have data lakes. You don't have a modern infrastructure. You don't have a data mesh in place, and you don't have the enabling data architecture, which makes it hard to scale. So data is the key enabler for teams to work with reusable components and a modern data infrastructure to work as independently as possible and minimizes as much waste and duplication as possible. So for us, it has been a crucial part of starting discussing a data abstraction layer. Just like a remote in your hand or in my hand is a way of abstracting the complexity of the underlying technology. A data abstraction layer for us is a way of getting away from the complex data infrastructure in the backend, making sure that the data teams can work on a modern data infrastructure and we can work on the modeling if we're representing data science and machine learning. And what we see in companies and what we see in H&M as well is that some of these, they are going directly straight to source today, making it hard to scale and hard to create reusable assets. What we also see, we have a shared layer, but then we do some things in between. How can we minimize the time we spend on feature engineering? Because that's a major part of any data science project. Data abstraction layer is where I'm going today when I want to do these things. And that's where I see that the future are as well. But still, the proof is in the pudding. We need to productionalize more. It's not just enough to do a proof of concept as we used to do with models in the past. We now also need to prove our point. So what we're now doing are not just talking about these AI capabilities. What we're talking about is creating data capabilities. I have a tendency of talking quite much about AI. But why I talk about AI is because that's part of the process that's most visible for people that don't understand what we do. All of us that works with AI and data science and machine learning, we know that data is the key enabler for us to actually be able to do anything. Crap in is crap out. No access, no work. That's what we're seeing. So our guiding principles are going to be based on proven architectural patterns for these type of things, where it's self-service, vendor agnostic, design for automation, operational efficiency, skill versus ambition alignment, and a modular architecture and cost transparency. I started with cost, I think, as one of the major things, but it becomes easy for us just to throw machines at the problem. That was the Hadoop solution. Just add one more node, just add one more node. I don't believe in it. I believe we have to be better and more efficient in the models we create and the code that we commit and deploy. So what we also look at then is creating a long-term capability stack. And for us, that is all about the ML engine. And all of you, I'm pretty sure, has read the Google paper about technical depth in machine learning systems. So I'm not even bringing that picture this year. I've done that so many times. But when we talk about the engine components, for us, it's about the different capabilities that we want to create. And how do we contextualize that into the best possible way? And for us, building on these capabilities, how do we do test and experimentation? How do we do execution and microservice layer on top of this? How do we measure? Because as you know, you're not successful until you actually can measure your results. And how do we capture the data, both on an outgoing and incoming basis? How do we do aggregation of the customer feature stores? And how do we do product feature store aggregation as well? So that we can continue creating a great customer experience for all of the H&M customers. So building on the capabilities, making sure we create a central engine component and then launching it. And then almost coming to the end of this presentation, I just want to highlight one of the most important parts in all of this. The AI literacy agenda. If you think it's hard negotiating with your stakeholders, if you're out there evangelizing more than you're actually in building things, there might be a gap in understanding what you're doing. For us, it's been a good journey because we had some business stakeholders from the beginning. Now that we want to have all core operational decisions amplified by AI, for us it's about really focusing on scaling these things out. Establishing product teams from our perspective that's actually going to go in and upskill the organization. Have teams to guide them, and also focusing on learning and development activities, and also, of course, constantly increasing the data literacy. My name is Errol Koolmeister, and I'm the chairman of the Nordic Data Science and Machine Learning Summit 2021. And it's been my pleasure of welcoming you to this event. Looking forward to connecting, looking forward to having lots of questions and discussions. Have a great event, and I see you later.